Split temporary variable is a technique that improves code readability and maintainability. It means breaking down one temporary variable into multiple variables, each with its own purpose or meaning. This makes the code easier to understand and modify later on. Hello guys, welcome to this lecture. Alright, let's begin by understanding what the split temporary variable technique is all about. Often, when we do calculations or operations, we use temporary variables to store values for a little while. But sometimes these variables end up storing more than one value, which can make the code confusing and cause mistakes. That's when the split temporary variable technique becomes useful. This technique recommends dividing these overloaded variables into different variables, each responsible for storing only one value. By doing this, we not only make the code easier to read, but also improve how the code is organized and maintained. Okay, this technique falls under the code extraction category in our refactoring diagram. Now, let's jump into a practical example to see this technique in action. In this example, the code calculates the perimeter and area of a circle using just one variable called result. After that, it prints out the values for both the perimeter and area. However, we can refactor this code using the split temporary variable technique to improve its readability and maintainability. In the improved code, we split the temporary variable result into two separate variables, perimeter and area. We also introduce a new variable called radius to store the value of the circle's radius, which is used in both calculations. When we split the temporary variable, the code becomes easier to understand, because each variable has a clear purpose. The names perimeter and area make it clear what they represent, which improves how easy it is to read the code. Additionally, using the radius variable helps in maintaining the code. It centralizes the value of the radius, making it simpler to modify if necessary in the future. Now, let's take a look at another example. Okay, in this one, the code determines if a person is eligible by considering their age and whether they have a license or permit. The result of this eligibility check is stored in a variable called isEligible. Okay, in the improved code, we divide the temporary variable isEligible into multiple variables to represent different conditions and intermediate results. First, we introduce the variable isAdult to check if the person is 18 years or older. Then, we have isEligible with license, which represents eligibility when the person is an adult and has a license. Next, we have isEligible with permit, which represents eligibility when the person is 16 years or older and has a permit. Finally, we calculate the isEligible variable based on the conditions of isEligible with license or isEligible with permit. In this example, just like the previous one, splitting temporary variable makes the code more understandable. Each variable has a specific purpose and plays a role in determining the final result of isEligible. Alright, to summarize, the split temporary variable technique enhances code readability and maintainability while reducing the chances of introducing bugs. It helps us better understand the code's logic, simplifies the process of debugging, and enables us to make future changes and improvements while keeping the code clear and easy to follow. On the other hand, there are a few things to keep in mind. This technique can be helpful in many cases, but it also has some drawbacks to consider. Firstly, it can make the code more complex, which can make it harder to understand. Secondly, splitting variables may lead to duplicated calculations, which can cause maintenance issues. Additionally, splitting variables can use up more memory, specifically in situations with limited resources. Managing the relationships between split variables can become complex, so it requires careful attention. Lastly, to ensure code clarity, it's important to use consistent names when splitting variables to avoid confusion and maintain readability. Understanding these drawbacks will help us make informed decisions when deciding to apply this technique. Okay, done. See you soon with another lecture.